A sweet number has the property that when it is divided by 16, the quotient and the remainder are the same. How many sweet numbers are there between 1 and 1000? Alright. Well, alright, so we take in a sweet number, right, and we divide it by 16, and we get some quotient, and then we get a remainder. We'll just say a remainder of r, okay? And that quotient and remainder have to be the same, so q is equal to r. Alright? So essentially, you know, this q and r are the same. So let's write this a little different way. A sweet number is equal to a multiple of 16. I could write it as 16q plus a remainder. Okay? And q and r are the same, so that's the same as, I could write that as 16r plus r. And I can rewrite that as just 17r. So that's telling us that sweet numbers are essentially multiples of 17. Alright? So let's make a little table here. We have just plug in values for r and get some values for sweet numbers. Okay, now the first one is going to be when I plug in 1 for r. Okay, so the first sweet number is 17. If I plug in 0, I'll just get a sweet number of 0, and that's too small. I'm looking for the ones between 1 and 1000. So when I plug in 2, I'll get 34, and I plug in 3, and I'll get 51, okay, and so on. So what's the biggest sweet number? Alright, well, we're looking for sweet numbers between 1 and 1000, so you might be tempted, like me. I did this wrong the first time. I took 1000 and divided by 17, and I ended up getting, what? I ended up getting 58 with a remainder of 14, so I thought, okay, 1000 is not a sweet number, but if I subtract 14 from it, I'll get a multiple of 17. So 986, if I plug in 986 or that 986 would be a sweet number, okay? And that would be when the quotient is 58, okay? Which would mean that you'd have, when you plug in 58 for r, you get 986. And then I thought, wait a minute, the quotient and the remainder have to be the same, okay? And when I divide by 16, the biggest remainder that I could get would be 15, right? That's the biggest remainder I could get. Because once a remainder of 16 is essentially a remainder of 0, right? Because that just means I have one more multiple of 16 in my number. Okay, so a remainder of 16 would be the same as a remainder of 0. So 16 times 16 would be, or no, let's see, 17 times 16 would be 16 times 16 plus 16, but that's the same thing that when you divide it by 16, you would get a remainder of 0. So the remainder and the quotient would not be the same. So, alright, so the biggest one we could get was when the remainder is 15. Okay, and when we plug in 15 for, if we take 15 times 17, what do we get? We get 255 is what I got, I guess. Alright, so 17 times 15 gives me 585, and then 17. So that's 255, okay? And that's our biggest sweet number, is 255, because once we go past that, we can't get a remainder of 16 or 17 or 18 or 19 when we divide by 16, because a remainder of 17 would essentially be a remainder of 1, right? Because that just means we have another 16 plus one more in that number, okay? So we're asked to find how many sweet numbers there are, And the answer, now I already circled, I should probably shouldn't have circled this because 255 is not our answer. The answer is that there are 15 suite numbers total, and that's it. So don't make the mistake that I did and just think, oh, all multiples of 17 are suite numbers, because even though this equation says that the suite numbers are multiples of 17, doesn't mean that all multiples of 17 are suite numbers. Okay? So, be careful. So your answer is 15.